Alright, this video is your first video for Standard 10. It's over solving inequalities. In this video, we will discuss one-step, two-step, and multi-step inequalities. Hopefully you can remember a little bit back from last year with inequalities. Some key points here are that on a number line, the graph of an inequality in one variable is the set of points that represent all solutions to that inequality. Two key points here is that we have an open circle, so we use an open circle not filled in if the inequality says less than or if it says greater than. If it happens to have an equal sign underneath both of them, then we would use a closed circle. So here's an example of a closed circle. So go ahead and write those two down. Alright, so let's look really quickly at one-step equations. In other words, we're going to have to either add or subtract to get the variable by itself. In example 1A, it says write an inequality that's represented by this graph. So this time we're actually going to be given a graph and we got to come up with an inequality. So let's go ahead and make sure that we can see the green. I'm just going to use the variable x to represent this problem. Notice how it is a closed circle and it is going to the left. Since it's going to the left, it means that it's less than negative 1.5. So we're going to say less than negative 1.5, and I also should put a equal sign underneath it because it's filled in. That means that it actually would equal negative 1.5 as well. All right, in example B, we've got an open circle at negative 6.5, but this time our arrow is going to the right. So again, I'm going to use x, and then I'm going to write my number down here, which is negative 6.5. And this time, I'm going to just put a greater than symbol because, again, it is an open circle. It is going to the right, so all these numbers are greater than it. So we've got to make sure that we say greater than. Sometimes students have pointed out in the past that if you see this arrow, do you see how it's pointing this direction? It also looks like a greater than symbol there. And then up here, it's pointing to the left, and it looks like the less than symbol. So maybe just a way that you can tell which is which. Example 2, solving the inequality and then graph our solution. Here we've got x minus 9 is less than or equal to 3. So I'm just going to simply add 9 to each side. So this is just like in the past of solving one-step equations. So we have x is less than or equal to 12. Okay. And then in order to graph our solution, I usually just start off in the middle with the number that I was given right here. And then, I don't know, you could go a couple above it or a couple below it. So maybe I start off with, let's just say 0. And then let's say 24. Again, these numbers really don't matter just as long as you have them in order, obviously. Since it's a less than or equal to symbol, I know I'm going to have a closed-in circle. So go ahead and close in your circle. And since it's less than or equal to 12, that means I have to draw my arrow to the left. It's less than. All these numbers would represent what I could put in there for x. Here we go with B. Again, we have the m on the right-hand side. So this is where what I wrote here in purple. It says don't forget to always get your variable on the left side. So I'll do that once we get done here, and I'll show you why. So here again, we're going to add 1/2 to each side. So now I'm left with m on the right-hand side, still is greater than or equal to. Just write that down here again. I'm at negative 1, I'm going to add 1/2 to it. So now I'm at still a negative 1/2. Before we graph this, we have to make sure that the variable is on the left-hand side. So I'm just going to flip-flop these really quick. But when I do that, I must switch this sign too. So it's actually m is less than or equal to negative 1/2. I highly recommend that you just switch it instead of trying to think of it the opposite way, because then you might get confused. Again, maybe I start off with my negative 1/2 here in the middle, and I don't know, 0. And then let's just say negative 1 here. Again, it's less than or equal to, so I'm going to have a closed circle. And it says that it's less than it, so I should go to the left once again. All right, guys, now what about if I have to solve one-step equations with actually multiplying or dividing? So just like before, we're going to multiply by 3 and multiply by 3 over here. So these 3's cancel out. I'm left with x is greater than 24. And of course, if I were to graph it, I want to make sure that it was an open circle and then drawing to the right. So open circle and to the right on my graph. All right, so the difference between example 3 and then verses 4 and 5, notice how we're dividing by negative each time. I want you to write this down in your notes. When you are multiplying and dividing by a negative number, be sure to reverse the inequality symbol, otherwise it won't be correct. So let me show you what I mean by that. I'm going to multiply this side by negative 6 and also multiply this by negative 6 as well. So then I'm left with x, and then 7 times negative 6 gives me a negative 42. And again, instead of saying less than, I must switch it to be greater than. So again, multiply by negative 3 here, multiply by negative 3 here. I've got x is, and then it's negative 2 times negative 3 is a positive 6. So again, I have to switch the sign. It was greater than, I have to make it less than. So very, very, very important note that you've got to remember in order to solve these problems correctly. Moving on. Okay, how about some multi-step inequalities? Oh, actually, not multi-step yet. These are just dividing. So we're going to have to divide by negative 3, divide by negative 3. And again, on the last slide, I said multiplying or dividing by a negative, you have to reverse the symbol. So this gives me x is less than negative 8. Okay? Again, divide by 5, divide by 5. So v is greater than or equal to negative 9. Now make sure you realize I did not have to reverse the symbol here because I didn't divide by a negative number. I divided by a positive number. So just because this number is negative doesn't mean that I have to switch it. Or just because my answer is negative doesn't mean I have to switch it. It's only if you're actually dividing by a negative like you are here in example A. Or also in example C. Again, we're going to divide by negative 6, divide by negative 6. So we have n is less than, oops, sorry, just actually telling you wrong here. So n is greater than, we have to switch it, negative 4. All right, on to multi-step inequalities. Guys, these are no different than what we've done with equations, okay? So you solve it just like you would if this was an equation. So again, I'm going to add 7 to each side. So now I'm left with 3x is less than 15. And then again, divide by 3, divide by 3. So x is less than 5. It also tells me to graph. So I'm going to come over here, just draw myself a number line. Now you only have to do the number line because we're just using one variable. In the future, we will learn how to actually graph it on a coordinate grid that has x and y, and that's when we have both variables. But right now, we just have one variable, so we can just use a number line. So again, maybe I put a 5 here, and I don't know, maybe I go up 10, and then I would go to 0 here. So again, it's less than 5, so I know I need to open circle on 5, and then it's less than it, so it means I need to go to the left. We like less thans, apparently. All right. Now, the second example looks a little bit harder, but please know that you shouldn't be scared of it. Let's see if this blue will show up very well. There we go. That does actually look good. I'm going to get my x's on one side, so I'm going to go ahead and subtract my 2x first. Always take care of the variables first, ladies and gentlemen. All right, so 6x subtract 2x gives me 4x minus 7 is greater than, again, these cancel out, so I'm left with 17. All right, I'm going to add 7. So these cancel out, I'm left with 4x is equal to, we've got, let's see, 14, 24. Again, greater than, divide by 4, and we have x is greater than 6. So again, I'll go ahead and graph it. Maybe I put my 6 in the middle. It doesn't really matter. Like, let's say I put a 5 here, and I put a 10 here, and I put a 0 here. All right, so if I'm on 6, again, I'm going to have an open dot at 6 because it's not greater than, or sorry, it's not equal to it. It's just greater than it. So I'm going to go to the right. Okay, so really make sure you, some people, you know, just write it right on the line. Some people do it above the line or above the graph that you draw. It's really up to you. I personally like it to be on top of the graph. All right, and of course, guys, we are going to have situations that have true statements or false statements. That's not going to go away. So we definitely need to identify the number of solutions of an inequality. Okay, so solve the inequality if it is possible. Remember that true means all real numbers or all infinitely many solutions, or also false means no solution. So again, these are multi-step equations. We have to distribute and solve for x and so forth. I'm actually probably just going to do a few of these. Let's see, 7 times 2x gives me 14x. And then 7 times negative 3 gives me negative 21. Lesson symbol here, 14x plus 5. And again, I'm going to subtract my 14x, subtract 14x. And notice how I'm left with 5 is less than negative 21. Well, do we agree with that? Yes or no? Hopefully you are saying no. 5 is not less than negative 21. So since it's false, we're going to say no solution here. No solution. Okay, let's take a look at this one. We've got 12x minus 1 is greater than, again, distribute. So 12x minus 6. All right, again, if I subtract 12x over there, and then I'm just left with negative 1 is greater than negative 6. And hopefully you said that that was true. So negative 1 is greater than negative 6. So we would say infinitely many solutions. Okay, so it's true. So infinitely many solutions. Hopefully you all can figure out what IMS means. Okay? All right, last one real quick. 5m plus 25 is less than 5m plus 17. Again, if I subtract over my 5m's, then they both disappear on either side. So then I'm left with 25 is less than 17. Is that true or is that false? Hopefully you all said false. So if it's false, then our answer would be no solution. Alrighty guys, here's your exit slip. Please make sure that you answer all 5 of these questions and come into class with your answers.